Alright, hello everyone. Today we're going to talk about lesson 10.3, which has to do here with arcs and chords. So our objectives will recognize and use relationships between arcs and chords, as well as recognize and use relationships between arcs, chords, and diameters. Right? And just so as a refresher here, a chord is a segment with its endpoints on the circle. So a chord is a segment with endpoints on a circle. And theorem 10.2 states that in the same circle or incongruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So that gives us that the arc FG is congruent to the arc JH if and only if the chords FG is congruent to the chord JH. So those arcs are congruent if and only if the chords are congruent. All right. And so let's use that theorem 10.2 here. Let's use that in this example. So in the embroidery hoop, chord AB is congruent to chord CD, so the segments are congruent. If the measure of arc AB is 60, find the measure of arc CD. All right, well in this problem, arc CD is congruent to arc AB because AB is congruent to CD. The chords are congruent. So that would give us that the measure of arc CD is equal to 60 degrees. Okay. So that's example one. If the chords are congruent, the arcs are congruent. Right. So example two here, in the figures, circle J is congruent to circle K, and arc MN. So the arc MN is congruent to the arc PQ. Well, if the arcs are congruent, then the chords MN is also congruent to PQ. So if the arcs are congruent, then the segments are congruent. So that gives us this equation: 2x plus 1 is equal to 3x minus 7. And we can solve this equation for x by subtracting 2x over, get all our x's on one side. We'll put a double up here and add 7. These cancel. These cancel out. Leaves me 1 plus 7 is 8 equals x. That's finding x. It asks for PQ. So we just need to use that. PQ is equal to 3 times x is 8, minus 7. So it's 24 minus 7, so PQ is equal to 17. Okay. So that's using theorem 10.2. Arcs are congruent if and only if chords are congruent. So now we're going to talk about bisecting arcs and chords. All right. If a line, segment, or ray divides an arc into two congruent parts, then it bisects the arc. So that gives us theorem 10.3. If a diameter or radius of a circle is perpendicular to a chord, so here we've got radius CB or diameter AB. Okay. If that is perpendicular to a chord, which it is perpendicular to chord XY, then it bisects the chord and its arc. So that tells me that XZ is congruent to ZY. It bisects the chord. It also bisects the arc. So XB would be congruent to BY. Right. And then theorem 10.4 states that the perpendicular bisector of a chord is a diameter or radius. So we have a perpendicular bisector, then it is a diameter or a chord. So that would mean in this example that AB is a diameter because it bisects the chord. So use a radius perpendicular to a chord. So in circle S, the measure of arc PQR is 98. So the whole thing here is 98 degrees. We want to find PQ, just this smaller segment. Right? Well, so clearly here, SQ is a radius. It bisects it. It bisects the chord, so it's also going to bisect the arc. So here we can just do the measure of arc PQ is 98 divided by 2. It's half of the whole arc there, so that would be 49 degrees. The measure of arc PQ. Here. So, and then they ask us to find in circle S, find PR. Okay, well, that radius, it's perpendicular to the chord, so that means it bisects it. So 6 plus 6, which is that PR is equal to 12. So we'll continue then. Example 4. Use diameter perpendicular to a chord. So here, we want to use in circle R, find TV, round to the nearest hundredth. So we are looking for the length of the chord here, TV. And so this radius is perpendicular to it. So we've got to use the Pythagorean theorem. Okay, if we take a look here, we've got this triangle. Right triangle. Okay, we've got that this is 6 and this is 5. In this triangle, okay, the radius, or in the circle, sorry, the radius is 11. Okay, so if we're looking, the segment RT is a radius, so it's got to be 11. So this segment here is 11. So we should be able to find, let's just label it X for now. X, get a little tough to read. Let's call that X. All right, and so if we can find X, then the arc, or excuse me, the chord we're looking for is just 2 times X. So TV would be 2 times X here because they're both the same. All right, and so to find X, yeah, you use the Pythagorean theorem. So 11 squared, the hypotenuse squared is equal to leg squared plus the other leg squared. You get 121 36 plus X squared. Subtract 36 from both sides. And we get that X squared is equal to 85. Square root both sides. We get that X is equal to, let's get here 2 times, well, 85. 9.22, around 2 decimal places. And so TV is just 2 times 9.22, so 18.44. All right. 18.44. So that's pretty good example there. You had to use a little bit of prior knowledge of the Pythagorean theorem to be able to solve that one. All right. So theorem 10.5. In the same circle or incongruent circles, 2 chords are congruent if and only if they are equidistant from the center. So these chords are congruent if and only if they are equidistant from the center. So if LX and LY are congruent, then the chords FG would be congruent to JH. All right? So that's if and only if they're equidistant from the center. So we'll use theorem 10.5 here in this next example. Right? In circle A, WX is equal to XY. Okay? So the chords are congruent. This tells me that the chords are congruent. Then we want to find AB. If those chords are congruent, then AB is congruent to AC. They must be equidistant from the center, so we can use that then to say 3x plus 4 equals 5x. Solving for x here, we get that x is equal to 2, right? And so to find AB, of course, we just plug 5 times x, which is 2. We get that AB is 10. Okay. The next example here, our last example, kind of just goes the other direction. We have to use here that these chords are equidistant, that HT and HU, those are equidistant, they're congruent. So the chords PQ then would be congruent to RS. So now we can use that and expressions here. So PQ is 3x minus 4 equals RS 14. 3x equals to 18, 4x is equal to 6. There we're only asked to find x, so we are done. All right, your assignment, 10.3, 719, page 719, 8 through 22, just the evens there. So good luck with that, and I'll see you all on Wednesday. We'll work on that assignment in class. That's after our DLD day. So thank you all for watching.